Hello guys, welcome back to Tronic Synergy. So last time we did a JK flip-flop, and there are many applications of using a JK flip-flop. You can make registers, you can make memory, and another application is to make binary counters. So today we are doing that one application of a JK flip-flop. So as you can see in the diagram, there are two JK flip-flops which are interconnected together, and they count binary. They basically count binary. Mine is a 2-bit binary counter, meaning that it has the two outputs of binary. So it can only produce 0 to 3, then back to 0. So if you can see 0, 1, 2, 3, then 0 again. So 0, 1, 1, 0, 1, 1, then 0, 0. So that's basically what a binary counter is, and that's what we are going to do. And yeah, hope you enjoy. So welcome back. So as you can see in the circuit that is in front of you, it's not a very hard circuit. It's pretty simple, just connecting two JK flip-flops together to make the binary counter. So at the input section we have a clock. Signal is fed in the clock area of our JK flip-flop, and the pulse is mainly controlled by the capacitor that you're using. If you're using a much bigger capacitor, then it's going to be much slower. If you're using a small capacitor, it's going to be a little bit faster. So the JK inputs of our first flip-flop, we connect them to a logic 1, meaning that we are connecting them to a power supply. They should just get continuous power supply so that they can flip from J to K, from J to K, then K to J, and so on. Then after that, we have the output. Q is connected to the clock. This is the clock input of our second JK flip-flop. Then the J and K inputs are connected high, just like as we connected the first JK flip-flop. Then the outputs. So the first output of our first JK flip-flops gives you A0. You can see it there in the output. Then the last Q gives you A1, and you can connect LEDs there to show you what is really happening and how it's counting the binary in 2 bits. Yes, to make a 3-bit, you connect another JK flip-flop. You connect this Q to that clock, then the J and K high, then the outputs will be this A0, A1, then the last Q will be A2. That will give you 3-bit binary counter. So the outputs should be looking like this. We have, when it's 0, it should be 0, 0. This is binary for 0. When it's 0, 1, it's representing 1. When it's 1, 0, representing 2. Then 3 is 1, 1. It should follow that order. Yes, it should follow that order in order to show you how the binary is being counted. So the circuit is right here. You can see it's pretty simple. I'm using a IC, the CD4027. It's a dual JK flip-flop integrated circuit, and I'm using both of the JK flip-flops. We have the input section right there that we talked about. We have the clock and the capacitor that is controlling the time. So if we use a much bigger capacitor, then it's going to be counting less fast. Like for example, if I'm using this is a 220, this is a 100 microfarad. If I'm using a 220, then I expect it to be much slower. So I'm going to put it and check the speed. Try to put it there. It's pretty small, but yeah. You see it's much slower than the 100 microfarad. These are 200 microfarad, but it depends on how you want your circuit to run. And the inputs are right there. The dip switch, both J and K are high. for the first one, and also for the second one. I've interconnected them, then I've connected them to power supply, meaning that they are also high. So it's, you can see it's already counting the binary. So 1 0 1, it's 1, 1 0 is 2, then 1 1 is 3, then it go back to 0 0, then 0 1, like that, then 1 0, then 1 1, then back to 0 0. So that's basically how a JK flip-flop can be interconnected to make a binary counter. Next time when I get one of these ICs, I'm going to make a 3-bit and even a 4-bit binary counter, which has much more LEDs to show you, and it can count up to 7 and up to 8 and so on and so forth. So thank you very much guys for watching. Please subscribe to Tronics Energy, where we do fun stuff all day, all time. So next time we'll pretty much go back to when we were doing the encoders and decoders, and we're going to try to make a 2-bit ALU. Yes, we're going to try to make a 2-bit ALU, and yeah, which will have maybe adders, subtractors, and some few logic operations. So thank you very much guys for watching. Please subscribe, and hope to see you next time. Goodbye.